I'm not recording, but I can. I've just started recording right now. And so what this person does is, his name is David Price. He was a graduate student at Stanford, and Jay Song is his co-author who works at Treasury. And they, what they do is they go back and they get this experimental data from the 1970s and 1960s, and they connect it to the tax records of those people that participated in the study. So what they're interested in is, let's look at the long-term effects of this experiment on the outcomes for the parents that were involved and for the children of the parents that were randomly assigned to these two different groups. And I'll show you the tables, but basically what's kind of super interesting, and let me see here. So we're going to talk about this today. This is an experiment. So experiments are nice because there's no omitted variables bias. Why is there no omitted variables bias? Because we're randomly assigning whether you get UBI or whether you stay in welfare. And because of that, your being in UBI isn't correlated with anything else. It's random. So these are the long-term effects of the parents who got UBI. And so I'm having a hard time highlighting, but this means that the folks that went into UBI, they were 3% less likely to be employed after the experiment ended. So UBI seems to have reduced their employment by 3.3%. Their annual earnings after UBI were $1,761 fewer each year after the experiment ended. And then they're much more likely to apply for Social Security disability insurance. So this is probably like the biggest effect, is that once you're used to getting money, that you are really trying hard to find another way of getting a guaranteed income source. So it's kind of conduces sort of other welfare enrollment, which is very interesting. So this is the main effects of how did it affect the parents that were enrolled. And then we're going to go look at, let me just see this really quick. Okay, so this is kind of interesting. So they break out the disability applications into what they were applying for. So whether they were applying because they had cancer, because they had circulatory disorders, musculoskeletal disorders, mental disorders, or other impairments. And what you can see is that the biggest effect is for mental disorders. And the reason for that is that it's very hard to verify whether someone has a mental disorder. So if I said, oh, I have arthritis, you can actually do an X-ray and you can see in my hands whether I have an extra buildup of calcium where my hands are hurting. So you could verify whether I have arthritis. For mental disorders, I can tell you that I'm anxious or depressed, and it's very hard to tell whether I actually am. And it's actually true also for back pain. So these are so it used to be in the 80s and before, you couldn't receive disability insurance unless you had a disorder that could be verified by a doctor. In the 80s, Reagan annihilated that. So Reagan said, no, you can apply for any number of things. He liberalized the program so you could apply for things that couldn't be verified. And there's been a huge growth, mostly in the areas that are not verifiable. So there's actually been very little growth in disability insurance for other programs. So it's kind of interesting. So this is the effects on the kids. Right here. So there were actually different treatments. There was the base treatment, which was, I think, 2 or 3 years. There was also a 5-year treatment. So these are people that were in the UBI program for 5 years instead of for 2 or 3 years. And then there were some other treatments that actually don't have much effect, but we'll be kind of focusing on those top 2 rows. So the first row says that in the basic treatment, when you were on UBI for a couple years, as a child, it has no effect on your employment as an adult. It has no effect on significant effect on your earnings as an adult, and it really doesn't have any effect on your Social Security disability insurance applications as an adult. It does seem to have big effects if you were on UBI for a long period. So if you're on UBI for 5 years, you're less likely to be employed as an adult. You're earning less, although this isn't statistically significant, but you're earning $1,300 fewer, and you're much more likely to apply for and then receive disability insurance. That's just kind of interesting. Any questions about that? So let's get into the material. Any questions from yesterday or earlier? Any questions? Okay. So I got the sense that you guys are really nervous about the test and that you don't know what to study yesterday. That was the feeling that I got from a few of you. And so I wrote up that email yesterday, but let me just articulate it again, because I think you have tons of resources to prepare for this exam. So first, you have all the slides that we've gone through. So that you should kind of think of the slides as the textbook for this class. I think when you read through the slides, you'll notice that they're very carefully worded to be as clear and as simple and straightforward as possible, that I build one thing on top of the other very carefully. So the slides are an enormous resource. If you're in the slide and you feel like, oh, I really don't understand what this means or how to interpret this, which I think in general, you'll be able to read them really simply, you can go and look at all of the lectures that have been recorded and posted to Canvas and YouTube. And then after that, you have basically 3 review resources already. So you have the review file for the midterm, which is under reviews and files. You have the review for the final, which is under reviews and files. And you have all the corrections for your midterm exam that you turned in as homework. So you went through and you answered and you explained to yourself why the questions you got wrong were wrong, and what you were supposed to do. So that is really a powerful review resource if you did that kind of diligently. And then we're going to have a review on Thursday, covering the review sheet uploaded on Canvas. We had a review last Friday where I answered all of your questions at 9 a.m. on Friday. We're going to do that again this Friday, where we're doing, I will answer any question that you have on Friday morning at 9 a.m. So you have tons and tons and tons of resources. You have all of your homeworks. You have new homeworks that I am writing that we'll work on today and tomorrow. So I just don't want you to feel like you don't have anything to study. You have tons of stuff, tons of material, and you can try different things. You can try the recordings. You can try the lecture slides. You can try the review sheets. You can try, and the example questions that we've done together in class are the best practice that you could have for the final, in addition, in my opinion, to the quizzes. The homeworks are great to review. You have tons and tons and tons of things, tons of resources. If you have more questions and you don't feel like coming to the review hour on Friday, send me an email and we can meet individually. We can meet at another time. But I just don't, I think it would be ludicrous to feel like you don't have the resources that you need to study for the exam. I've said this before, but I think that this is so important. The way that this material comes together for students is when they go through the slides or they go through the lectures and they write down the concepts, they write down a definition. What does it mean? How is it calculated? And they label every part of every formula, and they explain to themselves what it means. And then you go through that over and over again after you've kind of completed a review of all the material. And the thing is, it's still quite early. So you're 6 days out from the final, which includes a weekend and all of this week. And you can ask me any questions that you have to clarify anything. Every day at the beginning of class, I ask if you have any questions on previous material. If you have questions and you're not clear on something, bring it forward, because I am 100% sure that if it's not clear to you, it's not clear to 5 other people in the class. And so it's a huge service to yourself and other students to ask questions. And you can ask questions on Friday at the end of this week as we go into the weekend. So tons and tons of time, tons of resources you have, and you have everything that you need. I will not ask one thing that's not in the slides. I will not ask one thing that's not in the slides. It's a very straightforward exam, lifted, copied, almost word for word. If it were illegal to plagiarize, I would be in jail for plagiarizing over and over again from my own slides on the exam. The slides are an enormous and thorough resource on what will be on the test. Any questions? And also what do you feel like there aren't enough resources to study? Do you feel like I haven't given you the resources that you would like? I kind of was taken aback when this came up yesterday. It surprised me. So I would just want to make sure that I understand it. I probably should have asked that first. Okay. Anyone there? I can't tell if anyone's there. I think there's enough study materials. It's good to know that the slides are the safest thing to study. Yeah, the slides are very good. I mean, I don't know if they're good. They're as good as I can make them. They're as clear. And I've looked at other people's materials, people at Berkeley, people at UC Santa Cruz, people at Riverside. I think that my slides are the very clearest, the most methodical, the slowest to introduce you to a new concept. I think that there's enough study material now that there's more homework. A couple private messages. Okay. If you feel like Professor Johnston, all I would really need to do to succeed in this test is blah, you let me know. Email me, message me in chat, whatever, however, Facebook me, whatever you want, and I will provide the resources that you want. I had thought before yesterday that I had provided every possible resource for you to succeed on the test. So I was just shocked at myself that I may have missed something. If there's something that you feel like is missing, that's a resource that would help you on the test, please let me know, and I will do my best to provide it. Okay, so yesterday we began our discussion of differences and differences. So at first what we were thinking about were instances where we're interested in the effect of a policy. So we sometimes would do a thing where so this is actually a very common thing now that I'm so primed to think about COVID. So a big thing that's happened is that everyone has become a bad expert on everything in COVID, which is fun. So let's think about a time where we have mask mandates going into effect, mask mandates, okay? And we're interested in how effective these are in affecting the path of COVID. And so maybe we've got California, and California's COVID deaths are going like this, before and after the mask mandate. So I think this is about true. I can't remember the exact figure. It looks something like this. And so some dork says, but look, the COVID rates after the mask mandates are actually higher than they were before the mask mandate. So so it must be that the mask mandate is causing more infections. So that's not a good interpretation for a couple reasons. One, is that the trend line is actually increasing before the mask mandate. So it looks like this is just the disease is going, and and the mask mandate is not increasing the number of COVID deaths. So then say we had another state, and at the same time, as California does the mask mandate, they don't do a mask mandate at all. So we might have something like this. And then, I'm sorry, I wanted to kind of make it parallel. So what we find here is that even in the absence of the mask mandate, COVID deaths are going up. And what it looks like is that what is happening to the state without a mask mandate is very similar to what's happening to the state with a mask mandate. And so if this is all the information you'd have, you would conclude that the mask mandate is having a relatively small effect on the number of COVID deaths. And that doesn't mean that masks don't work. It might mean that people don't actually wear their masks, or that people are mostly contracting the disease in settings where they don't wear masks. So in home visits, for instance, or with family, within their apartment building, for instance. So it doesn't imply anything about the usefulness of masks exactly. It just means that the mask mandates themselves don't seem to do very much. And that's basically true. It's very hard to look at the data and find a case that mask mandates are doing a tremendous amount of good. Okay, so we've got, and they certainly don't seem to be making people sicker. So that's the other side of it. So what do we got in a difference in difference? We have two groups that we're interested in. We have a group that undergoes a treatment, and we're going to see them before and after they go through the treatment. So in our previous example, California is our treated group, and they have treatment just means that they're doing a reform that we're interested in measuring the effect of. And the control group is that we have a group that is not going to engage in the same treatment or the same reform. So that was in this case our other state. Maybe it was Utah or something like that, and this was California in our last example. Okay, so the purpose of the difference in difference. Remember when we were first doing. So let me do a simplified example of this last thing that we saw. So remember, we have mask mandates going into effect, and at first we just see California twice. We see it once before and once after the mask mandate, where this is time, where 0 is when the mask mandate goes into effect, and here we're going to say here's the death rate, the COVID death rate before the mask mandate and after the mask mandate. And we see that the death rate is going up after the mask mandate and before. It could be, if you only have 2 data points, you actually can't tell whether this is one constant trend or whether it looks more like this. So if this were the trend, we would think, oh wow, that looks like the effect of the mask mandate. If COVID deaths are kind of increasing smoothly, then we might think, oh, but we wouldn't know if we just had 2 data points. So then say we also had Utah, and Utah's like this here. So what we're going to think about today is that the simple difference, or the single difference, would imply that mask mandates increase COVID mortality. Okay. The difference in difference is going to say, well, look, we actually see the same pattern when we look at places that didn't do a mask mandate before and after California did their mask mandate. And what that would imply is that mask mandates have no effect, no significant effect on COVID mortality. Okay, so why is that? What's going on here? The key is that the control group is enabling us to see what things would happen in time that are unobservable. So what we basically don't know is, in California, how would COVID deaths have changed in the absence of the mask mandate? What we're going to use is the fact that Utah didn't have a mask mandate to see how deaths would have changed in the absence of a mandate. Let me check chat really quick. Are these groups related to the dependent and independent variables? Yes. So the independent variable, no, I'm sorry, the dependent variable is death rate. Dependent variable is death rate. And the independent variables are going to be whether you're in the treatment or the control group, and whether we observe you before or after the reform or the policy or the treatment. So let me stop here and just take a little breath and answer any questions that you might have. Cameron, Denelson, Derek, Devin, Esmeralda, Ibrahim, Katrina. All good? All good under the hood? My son started school yesterday, so we're very excited. Okay, we got some thumbs up. One thing that's funny about the thumbs up is I can't tell who is thumbing up. Can I? Let me see. Does it say? I don't know. Can't tell. But it's fine. It's just good to know someone's out there thumbing up. So this might seem funny at first, but we will do a few examples, and I think it will slowly kind of come in if you can marshal your attention and hear me. The purpose of the difference in difference. So let me say it another way that can be helpful. Is that by taking a difference over time within a group, we control for omitted variables that don't change over time. So that was kind of the clever thing about not comparing California at one point in time to Utah at one point in time, because many things are different between those two states that might not even be things that we could measure in a data set, like, I don't know, how religious they are and how careful about germs they are, things like that. The control group helps us to control for factors that do change over time. So we're basically, the difference in difference is allowing us to control for different kinds of things. Looking at California before and after they do their own reform or their own policy change allows us to control for the differences that are specific to California, and look within California at changes over time. And the control group helps us understand how California would be changing over time in the absence of a reform or a policy or a treatment. We assume that the control group would follow the same trend as the treated group would have in the absence of the policy, and this is usually called the counterfactual. So what is counterfactual? Counterfactual is, I might ask you this, what is a counterfactual? Counterfactual is what would have happened in the absence of treatment, where treatment could be anything, policy change, a reform, hurricane could be a treatment. What's the effect of a hurricane on some outcome, etc. Okay, so, and actually we got this far, I suppose, yesterday. So what we had initially was we had just DC. Remember, DC had a smoking ban. And so initially what we looked at was the difference in DC. How different was the hospital admission rate after the reform compared to before? And so we just would subtract 0.093 minus 0.121, and we got that the hospitalization rate went down by 2.8 percentage points, or 0.028. And then the difference in Maryland, we can do the exact same thing. We can take the after hospitalization rate less the before hospitalization rate, and we'll find that even in Maryland, where there was no policy change, the hospitalization rate fell by 0.8%. So when to do the difference in difference, we basically just take the difference of the two differences. That's why we call it a difference in differences. So we take the difference in California and DC over time minus the difference in Maryland over time. Oh, that's pretty cool. It seems to try to make it straight if I do it. Do you see how that's really straight? Like that looks like a box. How did I do that? How did I do that? That is so cool. Now I'm annoyed that I don't know how I did it. Okay, so but we're going to take the difference between those two, and we'll find that the difference in differences estimate is 2% or 0.02% reduction. So what does that mean? It means that there was a reduction of 2.8% in DC, but 0.8% of that reduction is accounted for in just the changes over time in a control city. Okay. So the difference in differences estimate is the following. It's the change in the treated group minus the change in the control group. So I could ask you on the test, what is a differences in differences estimate?
I think you need to hold it like for a couple seconds. It will like make it into a box. Like you just pretty much, yeah.
Oh, that is so satisfying. Okay, thank you, Leon.
And it works the same thing for circles and all that stuff, like a line. If you want a straight line, just hold it.
Oh,
Yeah.
that is awesome. Okay, thank you so much. That makes me so happy. Oh, I love it. Okay, thank you, Leona. The control group controls for the omitted factors that would otherwise cause us to get a biased estimate of the effect of the policy. And the key here is that we need a good control group. So if the control group is not a good kind of approximation of what would have happened in the treatment place or treatment person or treatment state over time, then we're gonna be in trouble again. So we'll talk about what makes a good control group. Any questions here? Let me check chat. Okay. So this is the way that we do it in a regression. So you can do it this way, where we just you just calculate what is the average hospitalization rate before in the reform in DC. What's the average hospitalization rate after the reform in DC? And then the same for Maryland. And then take the difference here and the difference here, and then take the differences of those two differences. That will give you the right answer. You can also do something, you can also just use a regression, and it will do all that work for you in one simple step. And the way that you set up the regression is the following. You have your outcome variable on the left-hand side, as we always do. And then we have three coefficients, basically, that we're estimating. Four coefficients that we're estimating, but three variables. We have an indicator for being the treated group. So that will be, it will be equal to 1 if you are, in our old example, California, and it will be 0 if you're not California, if you're Utah. 0 or 1. We'll have an indicator for after the reform. So this will be 1 if we observe you after the reform. So that's either post the mask mandate in California or post the mask mandate in Utah. So Utah never has a mask mandate, but we're going to have an indicator for whether we're observing them after California has done their mask mandate. So there will be a 0 if we're observing Utah or California before the mask mandate. And then we have an interaction term. Okay, and the interaction term is just the treated binary variable multiplied by the after binary variable. So we're going to have 4 betas come out of this. And each of these betas has a really intuitive meaning. Okay, so the first beta, beta naught, is the mean for the control group in the before period. So how do we know that? Because the untreated group in the before period is the omitted category. Remember, the omitted category is a category that's never named by the variables. So the omitted category is before and untreated. Okay. The beta naught plus beta 1 is the mean for the treatment group in the before period. So if we added beta naught plus beta 1, what we would get in our example up here, beta naught plus beta 1 will be right here. Beta naught plus beta 1 will give us 0.121. The beta naught plus beta 2 will be the mean for the control group in the after period. Sorry, just a second. Okay. And then finally, we've got beta 1 plus beta 2 naught plus beta 2 plus beta 3 is the mean for the treatment group after in the after period. So all of those 4 cells in the figure that I showed so it was Maryland before and after, DC before and after. We can calculate each of those 4 cells from the betas that we estimate in this regression.
Question?
Yes.
So for regarding the treat and the after, so the variable, do we just like assume that it will be like if for a non-treatment, we'll assume that it's 0 since it's not in the variable itself, right?
Yep. So if we had, say we had Nevada, and Nevada was in the data set and they didn't have a mask mandate, they would be a 0 in each of the times that we see Nevada, they'd be a 0 in the treated variable.
So anything that is not in the equation, we'll assume that it's 0. Like if the variable is opposite of what it shows in the.
Exactly. Yep, exactly. That's a great question, Liana. So if for each of these binary variables, if it's not treated, it's 0. If it's not after, an observation is not after the reform, it's 0. That makes sense?
So just a quick question again.
Yeah.
So if in the equation I have man, then that means I only assume that woman is 0, right?
Exactly.
And that will be the opposite. If woman is in the equation, then okay.
Exactly. Yep.
Yeah.
Exactly. Thank you so much for asking that. So I'm gonna demonstrate what the difference in difference estimator is in that regression. So we're gonna take treated before and after minus treated after minus treated before, and then we're going to have control after minus control before, and that remember from before is our difference in difference. So if I got you to remember one thing from this slide deck, it would be this right here. Difference in differences is the change in the treatment group minus the change in the control group. What's the difference in difference? It's the change in the treated group minus the change in the control group. So that's what we're doing here. We're going to have the change. We're going to calculate the change in the treated group, minus the change in the control group. Okay, that's the difference in difference estimator. We're just going to plug in. We know what these are from the previous slide. So the treated after is beta naught plus beta 1 plus beta 2 plus beta 3, those guys. Treated before is beta naught plus beta 1. The control after is beta naught plus beta 2. And the control before is beta naught. So what do we get from this? Well, we're going to have that beta naught will cancel out here. Beta 1 will cancel out here. And beta naught will cancel out here as well. So then what we'll have is beta 2 plus beta 3 minus beta 2. That's where this comes from. So what is the difference in difference estimator? It is just beta 3. So that's really cool. What that means is that when we estimate this regression, the estimated effect of the treatment is just the coefficient on this interaction term. Okay. Any questions here? So I'm not going to make you show this or anything like that, but it's just a way of demonstrating that. What do I want you to take away from this slide? Beta 3, that is the coefficient on treated times after, is the estimated effect of treatment. So if I give you this regression, I say, what's the effect of some policy change on the outcome? You wouldn't have to do very much. All you'd have to do is look for beta 3. Any questions here? Kimberly, Leanna, Levi, Neb, Noah, Oscar, Saul, Stephanie, makes sense. Yesenia, Warren. Okay. There's an alternative way of writing and thinking about differences and differences. So we've been thinking about it as the change in, I'm not going to test you on this. There's no way to test you on this. And we kind of need to make a little bit more headway today to get to the homework. But the idea is that you, instead of taking the difference before and after treatment, and before and after for the control and taking the difference, it's equivalent to taking the difference of the control and treatment after the reform has gone into place and before the reform has gone into place, and take the difference of those two. It's not an important it's not very important for your understanding. It's just to say there are different ways of thinking about what you're doing in a difference in difference. So say we have data for both the treatment and the control groups in the before and the after period. So this is what we had before. We have Mr. Malone, and he goes to a hospital in DC in 2000, and he doesn't go to a hospital in DC in 2005. We have Ms. Chambers. Ms. Chambers doesn't go to the hospital either time in DC. Ms. Jones goes to the hospital in 2000, but not in 2005 in Maryland. And Mr. Porter goes to the hospital in 2000, but not 2005. So this is just what the data look like for this example. And the key here that's different than what we've seen before is now we have data on two states. We've basically seen all this before, except we had only people in DC. Now we have some people in DC and some people in the neighboring state of Maryland. So we'll do a regression like this, where we have hospitalization as the outcome variable. We've got an indicator for DC. Remember that this is our treatment variable, actually, being in DC is the treated group. Year 2005 is our after variable. And then we have the interaction term, which is DC being treated, the indicator for being treated, times the indicator for being in the post-reform period. So you can translate this. This is equal to using the variable called treated. This is equal to the variable called after, and so this is equal to the variable called treated times after. So we won't always use treated and after and treated times after. We might use DC as a variable, in that you just have to know that DC was the treated group. So beta 3 is the difference in difference estimate of the effect of the smoking ban. Beta 1 is the difference between DC and Maryland in the pre-period. And beta 2 is the difference between Maryland in the pre and the post period. So basically, this is giving you the time trend using Maryland. And this is giving you the difference between DC and Maryland before the treatment. Okay, so why are these important? This is basically allowing you to control for the differences that exist between DC and Maryland even before treatment. And this is allowing you to control for the differences in the outcome that would have taken place over time anyway in DC. And that's being identified or informed by what's going on in Maryland, who hasn't had any treatment. Let me check my chat. Straightforward. Okay, sounds good. Any questions here? So this is a really important slide too. If I could get you to memorize the second part of this deck, where the first part being that the difference in difference is the change in the treatment group less the change in the control group. The second part would be to really massage into your mind what these betas are. The beta naught is the hospitalization rate of the control group before the reform takes place. The beta 1 is the difference between the treatment and the control group before the policy takes place. And beta 2 is the change in hospitalization, or the change in any outcome that takes place over time, which you're learning from the control group. No worries. No worries. Go take a lie down. Okay. So this is the regression that we would get. These are the coefficients that we'd get. So now that we can read all the coefficients from the before and after matrix, what would we estimate the policy effect to be if we only had DC data? So we can do this again. Say we only had DC data. How would we estimate the effect using a single difference? We would take the hospitalization rate after the reform, 0.93, minus the hospitalization rate before the policy, 121. So this is just the change in hospitalization rate in DC, and we would get 0.028. Okay, so that should look a little familiar. What do we estimate the policy effect if we also have data on Maryland? Well, what we're going to do here is we're going to calculate the change in DC minus the change in Maryland. Okay, so that is going to be negative 0.028 minus, and then the effect in Maryland. We'll just do that really quick. So what is 0.117 minus 0.125? This change is negative 0.008. So we will subtract off negative 0.008, which gets us negative 0.020. So the difference in difference is going to give us an effect of negative 2%. And the simple difference is going to give us an effect of almost 3%. So these two estimates are actually almost 50% different. They're very different from one another. Questions here? This is a really important slide.
So a quick question.
Yes.
What is that negative?
What's the negative?
Yeah. Does it change if we put a positive instead? What is that negative represent? The negative sign?
Yeah,
or,
this one right here.
No. For the answer, like for the negative 0.028. Like, I mean, what if we have a number that's bigger minus something that's smaller, and then we'll get a positive number, right? So what is that different between? You
could get changes that are positive. The key here is actually it doesn't super matter which way you do it, as long as you do it consistently. So if you're doing after minus before for DC, you also need to do after minus before for Maryland. And the way that I think about it is that I'm to see how it's changed. I'm doing before, after, and then comparing it to before. So I do 0.093 minus 0.121. And then here I'm going to do 0.117 minus 0.128. I'm trying to think if I had done it the other way, I think I would have gotten positive 2%. Is that what you're asking? Does it matter whether we use a positive number? Does it matter whether we do after minus before? Can we also do before minus after?
Yeah. And I mean, like, what if the answer we got, the answer, like at the end, we get like negative number, right? And then what is that negative? Will the negative sign affect anything to the answer at the end or no?
So the negative sign, oh, you mean this sign down here? Are you talking about this sign right here and this sign right here?
Yeah. What?
So
I mean, will that affect anything?
Yeah, so those will definitely affect it. So if I had put a plus here, I would have gotten negative 0.3036.
Like I'm saying, in like how would the interpretation of the answer would be different if we have a positive answer instead of a negative answer?
Oh, sure. Are you just saying? Are you wondering how would you interpret it if instead when we did this math, we got 0.020 instead?
Yes.
So the whole example is different, but we get it as, so then the what we would find, what I would say is the estimated effect of this policy is a 2% increase in whatever the outcome is.
So the negative means that it's a 2% decrease?
Exactly.
Oh, okay. Yeah, that's my question. Right.
Okay, good. Sorry, it took me a while to figure it out. That's a really important question. Yeah, so that means it's a 2% decrease in the outcome because of the treatment. Okay, any other questions? Thank you so much, Leanna, for asking that. So I think that's really helpful to a lot of students. Okay, what should we look for in a control group? So when we're picking out a control group, what we want is a group that is similar to the treated group, but doesn't have other changes going on at the same time. Okay. We are probably going to start it today. Well, after I finish, we're on the last slides of this deck, and we'll get going on today, and then we might finish it tomorrow. Is that okay? So we're looking for a control group. So here's a good example. So say we had, California is doing this mask mandate, and our comparison group is Nevada. And Nevada doesn't do a mask mandate, but they do some other big change to their to some big policy intervention at the same time or a similar time as what California did. It might not be a good control group because it is changing in a way that California is not changing. So it doesn't tell us very much about the time trend that would have happened in California absent its mask mandate. So we're looking for a similar group that doesn't have that is going to be changing in similar ways over time in the absence of the policy. So usually we think it doesn't have other weird things going on. It doesn't have other big treatments. So why do we use the regression equation instead of summing everything up, differencing everything by hand? Well, it allows us to calculate statistical significance really easily, and it allows us to add control variables. So in our example here, we had this could be this is our difference in difference specification, and then we can include other controls, which is really, really useful, really helpful. Okay. Let's see here. I think. Oh, bother. Okay. So this is a secondary example from just like what we just did. Let's do it together really quickly. So what should we look for in a control group? So here we have in 1992, New Jersey increased its minimum wage from $4 to $5, and we have data for 1990 and 2000. We're interested in estimating the effect of the policy on employment. So what should we look for in a control group? Usually what we want is a nearby state that did not have a minimum wage change and didn't have other changes. Okay, what does the regression look like? Well, we're going to do a regression like this. It's going to look like the outcome variable will be employment is equal to beta naught. It's beta 1 times New Jersey plus beta 2 times year 2000 plus beta 3 times New Jersey times year 2000. So that's our interaction term. Okay. What additional control variables should we include? Oh, that's a toughie. Anything else that we think might be affecting employment over time. So what would that be? We could, I don't even know, like maybe stimulus, like federal stimulus differences. Sometimes in some industries, weather. So like when it's really cold, construction and landscaping go down. When it's wet, you can't pour concrete, so housing stops. Okay, so this is another example of the same thing. And I think that you'll be able to do it. I just want to be able to, it's the exact same question. So you won't, I don't think I'll convey anything new by doing another example of this. Sorry. So let's talk a little bit about how we choose good control groups. So if we were looking for companies, so say we have a single company and they implement a new salary policy, and we want to see how that affects turnover, how it affects productivity. What we might be looking for is companies that haven't done a similar policy, but that they work in the same or in a similar industry. We want to look for groups that are actually similar, and we might look to compare them to other companies of the same size or a similar size. Say we were studying wages, and we had some sort of policy change that was going on in for some workers, but not others. We might be looking to compare them to people with similar education levels, living in similar places, maybe in similar industries. For health outcomes, we want basically the people to look like what the treatment group would look like in the absence of treatment. So similar ages, similar gender, and similar health at baseline. So all we're trying to do in a control group is find a group of people that looks like the treatment group but isn't treated. That's kind of the fundamental thing. And then the last two slides are just a data output. So I'll just show this to you in part so we can talk about statistical significance. So remember, we have three variables that we put in these regressions. We have an indicator for being after the reform, an indicator for being treated, and an interaction term of treatment and after. So what do these mean? After just means, this coefficient means how much change is there in the crime rate after as compared to before the reform in the control state, in the control area. The treatment is what is the baseline difference between the crime rates in the treatment places and the control places. And then this is the treatment effect, the effect of the policy on the crime rate. And so you can see it's actually quite small. And when we look at the standard error, we can calculate the t-statistic. So how do we calculate the t-statistic for this treatment effect? We say minus 0.00169 minus 0. Why are we subtracting 0? Because that's the null hypothesis. Divided by the standard error of the coefficient, which is 0.00455. That's going to give us a t-statistic of negative 0.37. So is that statistically significant or not? What do you think? So it's less than 2. So it's not significant at the 5% level. Okay. Any questions on this? Okay. And thanks to those that are messaging me privately too. I understand you don't want to say everything in front of the whole class. Okay, so we're going to take a quick break, and then we're going to get going on the homework. Let me put okay. Let me pull up the homework. So this is going to be about a little bit about confidence testing, critical value significance testing, and a little bit about differences and differences. So this is actually a really interesting natural experiment that took place in that economists have taken advantage of, which is that between 1970 and 1980, the Indonesian, oh, I need to share my screen, sorry. So this is uploaded onto Canvas, but we'll look at it together here. So the Indonesian government built more than 60,000 new elementary schools between 1970 and 1980. And that significantly reduced the distance that some children had to walk to get to school. And at the time, schools were built in areas that the government deemed high need. These tended to be lower, less educated areas. And then there were obviously other areas that were less high need or they were low need. And what we want to do is estimate the effect of the total number of years of schooling that children received. And so what we're going to do is collect data on the years of schooling attained by a random sample of citizens in the country prior to the policy in 1970 and then after the policy in 1980. And so here's our little table. So this is the average years of education attained before and after the policy in high need places. And then here we have the same, which is the years attained in education in 1970 on average, and then the same in 1980 in areas that didn't receive all these new schools. So use the table above to write the regression equation that you would need by running a single difference specification to estimate the effect of the policy. So this first one what we would find is a single difference is going to look like this. Education is equal to beta naught plus beta 1 after. Okay, and we know what the beta 1 will be and the beta naught. So this would be a regression only using people in the high need area, and the beta naught would be 5.12. How do I know? Because it's the omitted category. So it's it's just the average education attainment in the omitted category will be our beta naught. And then beta 1 is going to be the difference between the after and before. So it's going to be 6.85 minus 5.12 is equal to 1.73, hopefully, after. So the estimated effect here is 1.73, and we can get all of this from this difference in difference table here. Okay, so that's kind of cool. Any questions with that? Imagine the coefficient on year 1980 in your regression was 1.73, and the standard error of the beta were 0.51, and the variance of the error term were 1.21. Okay. So here are the numbers that are given. Is the coefficient statistically significant at the 95% confidence interval? So the first question is, what do we need to calculate what do we need to calculate the t-statistic? Okay. What we need is the following. We need the beta minus 0 divided by the standard error of the beta. Okay, so here I'm trying to trick you because it says the variance of the error term. So I'm trying to trick you that this is what you need, but that's not what you need. All you need is the standard error of the beta, which is this 0.5. So we can calculate the t-statistic just like this: 1.73 divided by minus 0, I'm sorry, divided by 0.51, and that is going to give you a number that is at least 3. I know that it's at least 3 because 3 times 0.51 would be 1.53. So this is going to be greater than 3. And 3 is greater than 2, which is our critical value. So it's significant. 3.39. Okay, thank you, Anne. Appreciate it. Okay, so is the estimated effect of the policy statistically significantly different than 0? Yes. Yes, it is statistically significant at the 95% confidence level. Okay, any questions on that? Should not delete it until I see if there are questions. Okay. Any questions there? Okay, so now you want to do a difference in difference strategy. I list 3 important characteristics that low needs regions would have in order to be a good control group. So a couple things. To be a good control group, they have to not receive treatment. So what does that mean? If there were a bunch of school building in the low need group for other reasons, like say they also got government money to build schools, then that would make it a bad control group. 2 is that so no other policies affecting educational attainment. And 3 is that it would have to behave like treatment group in the absence of treatment. So other things that you could think of. Those are the main 3 that come to my mind. You wish to do a difference in difference, those 3 important characteristics low need schools would have to have in order, regions would have to have in order to be good control groups. So the main thing that you're actually looking for is a place who would be trending like the treatment groups, but it hasn't been treated. It's trending like the treatment groups in the absence of treatment, but it hasn't been treated. So usually what we do is we look at the treatment group and the control group before. So here's the date of treatment. What we are interested in knowing is if that's not what I wanted. If the 2 groups are trending in parallel before the treatment takes place, we say, oh, this control group is a nice control because it's trending exactly like the treatment group before the treatment group is treated. So that's key. Letter C. Okay, now use the table above to write the regression equation that you would get by running a difference in difference specification. What is the estimated effective treatment? So these are good practice questions for the test. This is definitely something that could be on the test. So what we're going to have is education beta naught plus beta 1 year 1980 plus beta 2 high need plus beta 3 year 1980 times high need. Okay. So what are these estimates? Well, beta naught is going to be equal to the omitted category. So that's the low need in 1970. So the before untreated group is going to be beta naught. So we get 7.22. What's beta 1? Beta 1 is going to be the difference that's going on in the control group after treatment. So what's the difference between these two cells will be beta 1. Beta 1. So that will be 0.48 minus 0.22 is 0.26. So that will be 0.26. So what does this, all this means is that the control group is going to increase by 0.26 years of education on average after treatment compared to before. Beta 2 is the difference between the high need and the low need in the pre-period. So that's going to be 0, 9, I'm a little foggy. Does someone have that? I went to bed really late last night, if you can't tell. Okay, I can do it another way, actually. It will be 2.10. Does someone have that? Something like that? So the difference between the treatment and the control group before treatment will be this beta 3, and that's going to be negative 2.10. And then the beta 3 will be the difference in difference. So we can calculate that up here. Let's see, that will be minus 3, 7, 1. I'm sure that's plus. I think we've already done this one. Plus 0.26. And so we'll take the difference of those two, and that will be 13, 6, 7, 4, 1. That will be 1.47. Okay. So that is, if we ran this regression with that data, these are the coefficients we'd find. So this would be a very fair test, and you can follow the logic both from the slides or from the recording or from reverse engineering from the homework. Okay. What is the estimated effect of the treatment? So this is definitely a question that will be on the test. Which is the estimated effect of the treatment? It says beta 3. So we think that the effect of the treatment is that education is going up by 1.47 years. Okay. Okay. Any questions there? Okay. So E is also a statistical significance question. So say the coefficient on year was 0.26 with a standard error of the coefficient of 0.21 and a variance of the error of 0.04. Is the coefficient significant at the 95% confidence level? So to find that, we're going to go 0.26 minus 0 divided by the standard error of the coefficient is 0.21. So we're going to get a number that's a little bit greater, a little bit larger than 1. Okay, and that's less than 2. So that estimate is not significant. Okay, at the 95% confidence level. Is this supposed to be the effect of the policy? Is this the effect of the policy? No. This is not the effect of the policy. The policy, but the change in education in the control group. The effect of the policy is the coefficient on the interaction term, which here is beta 3. Okay. Any questions here? Okay, compare your results in part D to your result in part A. Carefully explain why they're different. Okay, so I can't remember. What was our effect? What was our D? So A was, the effect was, can someone name it back to me? Okay, 1.73. What was the estimate in D? 1.47. Okay, so so the effect in D in A was larger than the effect in D. This is because the single difference does not account for changes in attainment over time that would have happened in the absence of the policy. So what do we get from the difference in difference? We're using the control group, the low need group, to see how education, so because you can just imagine the education is going to be drifting upward over time for reasons that are unrelated to building schools. So whenever we're doing a simple difference, we're worried that that some of the gains that we're seeing or the losses that we're seeing would have happened even in the absence of any policy. And what the control group allows us to do is gauge how much of the change over time that we see in the treatment group would have happened anyway. And so that's what's happening when we're subtracting off the 0.26, which is the increase in the attainment in the control group. We're subtracting off that difference from the difference in the treatment group. We're essentially controlling for the changes in education attainment that would have taken place anyway. Any questions there? That is a really cool, differences and differences are very fun, very cool, kind of simple and elegant and mostly transparent. So they're kind of fun. Any questions? That's the whole of the homework. We smashed it in the nick of time. Yeah, was it too fast? I was trying to get through it. We had it all good. It's all in the recording, so that's one thing. Oh, good. It is kind of intuitive, but sometimes I feel like I'm saying the same words over and over again. So I'm like, does it make sense? The difference and the change and the subtracting and the subtraction and the, all that stuff. Okay. You guys are going to do great on the test. I know you're going to do great. Please, please, please let me know if there's a resource that you would like that is not available. Let me check on Canvas really quick. I could have missed that. Files. So it's assignment6.pdf is on Canvas under assignments in the files tab. When is it due? That's a great question. The assignment will be due. Why don't we make it due tomorrow? That way we can do maybe one more assignment. Do you guys still want another assignment this week? The sense I got on Monday was that you wanted multiple additional assignments. I see the file, but not the submission. Oh, not the submission link yet. Yes, sorry. Let me do that. Assignments. Thank you. Thank you. I would have forgotten that for sure. Okay. It will be available today and due tomorrow. Can't believe it's already August. Okay. Will the lecture be posted today? Yes. What is the quiz XP that's due on Saturday? So there won't be a quiz on Saturday, I don't think. When I write quizzes, sometimes it automatically does a due date. Let me just make sure that's, let me go in and change that. That was basically, let me see if that is anything. Edit. Yeah, it's and the material in it you would crush. It's like, what's a multivariate regression? So it's all old stuff. So let me just change this. Why is it published? I don't understand. I'll just push it back. Oh, you know why? it like demands that it's assigned to somebody. And it won't let me make the due date after or before class. I'll just delete it, I guess. Let me see if I can. Unpublish it. Okay. Will the lecture be posted today? Yes. I think with the remaining time, I would rather review our current assignments and resources to prepare for questions for Friday. That's a great idea. Okay, so and if you, yeah, I think that's a great idea. If you are feeling like I would love questions about something, let me know what that would be. You can email me or you can put it in chat right now, and I can just make questions for you, and you can work on them. And but I do think at this point it's probably better to start reviewing than to do more homework, is my guess. Okay. Cool. I have every confidence that you can do it. It is in your ability to do well on this exam and to prepare. I have honest to God, I've done everything that I know how to do to give you every resource that I can think of that would be helpful. And now it just takes the doing part. Yeah, I think so too. I think you're going to do great. Yeah, please email me if there's something that you think something I can provide that would be helpful, and I will do my best to provide it in a timely way. And do not worry about your homework grades. Do not worry about your quiz grades. There's lots of grace in your quiz grade. I think you saw in the midterm how much kind of movement curve there is in the class. I don't want to be giving D's and C's. I want to be giving A's and B's. And so there's just going to be, I'm going to drop your lowest homework grade or your lowest quiz grade. There's extra credit if you all do your course evaluations, which it has happened every time, I think. The best practice worksheets would just be the slides. The slides have so many example questions. You could redo the homeworks. I can, but you would like a practice. You want like a practice test? Is that what you're looking for, Warren? I don't have one of those, but I can try to. What if I did this? What if I go into the test and I write kind of like 10 questions that look like test questions? I'm not going to give you the exact same test with different numbers, but I can give you some more questions that are like the test questions. I mean, so that you kind of know what's coming because you've taken the midterm, you've taken a few quizzes in the class, so you know what the multiple choice questions are, how I write them. And from class, I say, and I think I literally give away like 80% of the questions or 90% of the questions where I say, this would be a great test question, or this is a really important subject, or this is the core of the class. Those are the topics and the questions that you're going to see many times. So let me take some time this afternoon to write like 10 sample questions from what you might, of things like what you would see on the final. I can do that. And I'll upload it into the review tab. Okay, yeah, that's a great idea. Okay, but I guess here, I'll just tell you a little bit why I think it's not the best way to learn the material. Is what usually happens when you use sample questions is you learn pattern matching. So you're not learning econometrics, you're learning the style of the correct answers and the style of the kind of the it makes it so that you're not really learning the material. So I'm very loath to produce like a careful, because I just think you'd learn, oh, well, I don't understand this at all, but I know how to get the right answer on this problem. And that's what I want to avoid. So that's why I want to grow out from the principles, from the material in the class to prepare you for the test, rather than saying, this is the problem that you're going to see. But candidly, I've given you literally hundreds of practice problems in the slides. And we've literally done hundreds of practice problems together in class between the homework and the slides. But I'll go and write some questions. In part, I'll try to write questions that will kind of stretch you. Then we should be good with the slides. Awesome. Cool. Honestly, I have a ton of confidence in you guys. You guys are bright. You guys are hardworking. You guys are on your game. And I think you're going to do great on the test. And I'm sure that you're going to do great in the class. So if you're still here at 12:06, you're going to do great in the class. So. Sounds good. Class is dismissed. You're welcome to get along with the rest of your day. Please start studying today. If you haven't already, please, if you have started studying already, commit 2 or 3 hours. Start going through the material and write notes. Yeah, of course. Thank you.